Welcome to educator.com. This lesson is about solving addition equations. In this lesson, you're going to learn about solving addition equations. And ways that you could use this are to find change in height or weight of an animal as it grows. There are several vocabulary terms. First, an equation is a mathematical sentence that has an equal sign. So you've probably worked many times with expressions, such as just x plus 3. Well, now it becomes an equation when you put an equal sign and set it equal to another value. If you look at the word equation, you're going to notice that it almost has the word equal in it. So that can remind you that an equation is a sentence, mathematical sentence, with an equal sign. So this would not be an equation because there is no equal sign. Isolate. Isolate next means to get the variable alone on one side of the equal sign. Maybe you've heard on TV or something that when a person is in isolation, they are alone. So you can think that isolate means to get the variable alone. Inverse operations are operations that undo each other. Another way to think of inverse is opposite. Opposite operations. So operations that undo each other. For example, addition is the inverse to subtraction. And multiplication, oops, let me rewrite that. Multiplication is the inverse to division. Those are operations that undo each other. So if you add something and subtract it, you've canceled out the operation. Let's look at the subtraction property of equality. The subtraction property of equality tells us that if you subtract the same value from each side of an equation, the two sides will remain equal. So for example, if 12 plus 4 equals 16, I have a mathematical equation, a mathematical sentence, which is an equation, and now let's subtract the same number from both sides. So for example, if I subtract 4 from both sides, 4 minus 4 is 0. I'm left with 12. And notice over here, 16 minus 4 is also 12. So when I've subtracted the same number from both sides, my answer will be the same. So I'm keeping it equal by doing the same thing to both sides. In algebraic terms, if you have A plus B equals C, and you subtract B, B minus B goes away to 0, and you have A, and now over here you have C minus B. So when you originally began with A plus B, you now have C minus B after you've subtracted B from both sides. Notice that the sides have changed. So remember to always subtract the same from both sides when you're solving equations, because there's an equal sign in the equation and we want to perform equal operations to both sides. Let's try looking at inverse operations in order to solve addition problems. We have 38 plus x equals 42. And remember, like we talked about, we want to isolate the variable. We want to get x alone, because eventually if I can work it down where x is alone, I can see what it equals. So let's start off with 38 plus x equals 42. I have a positive 38. Remember that we're going to focus our attention on what's in front of the number. When there's nothing in front of the number, we know it's a positive value. We just assume that it's a positive. So the opposite of positive 38, or adding 38, is subtracting 38. Let's subtract 38. I'm using the subtraction property of equality because I'm subtracting the same number from both sides, subtracting equally. 38 minus 38 cancels out to 0, and I've isolated x because x is all alone here. And now I can subtract on this side. Borrow, 12 minus 8 is 4. So x equals 4. So I've isolated the variable, I've gotten it all alone, and now it reveals to me what the value of x is. It's a good idea to use substitution to check your answer. Although it takes a little bit longer, in the beginning when you're learning about solving equations, it's a really good way to check and make sure that you're understanding what it is that you're doing. So what that means is I've just found out that x equals 4. So I'm going to go back to the original equation here and put 4 in. And if I do get the answer 42, that means I've done the problem correctly. 38 plus 4 equals 42. And 38 plus 4 is 42. So yes, it's true. I've done the problem correctly, and x does equal 4. Let's try the inverse operation here. The opposite of plus 7.3 is to subtract 7.3. 7.3 minus 7.3 cancels out to 0. Remember that when you subtract decimals, your decimals should line up. So I'm going to borrow. This becomes 11 minus 3 is 8, and 8 minus 7 is 1. And bring down your decimal, 1.8. So that means y equals 1.8. Let's go back and check our answer using substitution. So in place of the y here, I'm going to put a 1.8. 1.8 plus 7.3 equals 9.1. If we did it correctly, the answer should, when I add these two numbers, the answer should be 9.1. So I'm going to add my decimals by lining up the decimals. 8 plus 3 is 11. 7, 8, 9. 9.1. Yes, it does work out. So y equals 1.8. Let's try drawing a model. Sometimes that might help you understand how to set up your equation if you're writing a word problem. And the idea for the model is that a part plus a part will give you the whole. Let's look at this example and draw a model for it. A puppy weighs 5 pounds. Over the next year, it gains g pounds. Now it weighs 12 pounds. How much weight did the puppy gain that year? So, in the beginning, the puppy weighed 5 pounds. It gained a few more pounds. Let's call that its gain for G for gain. And after it gained the pounds, its total weight, what it equaled altogether, see how the bars line up, was a total of 12 pounds. So that means when I do 5 plus G, I get the total, 12. So here's our equation. Part, in the beginning it weighed 5 pounds. Then it gained some weight, we don't know how much, G, and that gives us the total of 12. Remember that the information you don't know is your variable. Variables always represent the unknown. So how much weight did the puppy gain that year? We're looking for the gain. And so that's why that's our variable. 5 plus G equals 12. Let's subtract 5 from both sides, subtraction property of equality, and G equals 7. Let's go back and check our information. The puppy started out at 5 pounds, he gained 7 pounds, and now he weighs 12 pounds. How much weight did the puppy gain that year? 7 pounds. Remember that you always want to answer a word problem with units. And our units here would be pounds. Let's try drawing another model. A mountain climber started his second day at 250 feet elevation. After a day of hiking, he ends up at 621 feet elevation. How many feet did he hike that second day? So let's say that this hiker has already gone up the mountain 250 feet. Write it sideways. Let me fix that too. So he's gone up the mountain 250 feet. He stops there for his nighttime rest. He camps out there. And on the second day, he continues hiking up. And we don't know how much he hiked. I'll call that H for how far he hiked. You could call it any variable you want. But we do know that now he has reached a total of 621 feet. So once again, we have our part plus part equals whole. So the first part, this 250, plus the second part, the H, gives us the total, the 621. So our equation now is 250, the first day's hike, where he starts on the second day, plus this entire second day's hike equals his total height, 621 feet. Let's subtract what he did the first day to reveal to us how much he hiked the second day. 250 minus 250 is 0. And h equals, his second day's hike equals 1. 12 minus 5 is 7. And 5 minus 2 is 3. So on his second day, he hiked 371 feet. Remember to include your unit of feet. Let's go back and check that that's what the problem was asking for. How many feet did he hike that second day? And yes, on the second day, he hiked 371 feet. Let's try some examples by writing equations without drawing the model. A store owner is selling a sweatshirt for $49.95. He paid $25 for the sweatshirt. How much profit is he making? So when you go into the store, you see the sweatshirt that costs $49.95. And you know that the store owner paid $25 for the sweatshirt because maybe you've seen it online somewhere else. And you want to know, how much is the store owner making? Is he getting too much money from you? Let's take $49.95, the total price that the sweatshirt costs, and let's subtract how much he had to pay for it to find out how much he'll be making. 9 minus 5 is 4, and 4 minus 2 is 2. So he's going to be making $24.95. So he's almost doubled the price of the sweatshirt here. He paid $25, and he's going to be making an extra $24.95 on the sweatshirt. Let's go back and check the problem, make sure we've answered it correctly. How much profit is he making? Okay, let's include our unit. He's making $24.95. A car dealer bought a used car for $2,000. He made some repairs that cost him $600. He then sold the car for $4,500. How much profit did he make? So this car dealer found an old car and bought it for $2,000. So he's spent $2,000 at this point. And he made some repairs that cost him $600. All right, so he's spending $600 more. He's then sold the car for a total of $4,500. How much profit did he make? So you could do just the arithmetic and say that he spent $2,000 and then spent another $600, and you would get that he spent a total of $2,600. And then you would see that he's selling the car for $4,500. And so that's how much money the buyer would give him. And you want to subtract how much money he spent to find out how much money he would actually get to pocket. And that would give us, he would actually be making $1,900 profit. Well, let's check how we could write this with an addition equation, including a variable. Here we've done it the arithmetic way without a variable. So how much profit did he make? Remember, if you're having a hard time getting started, that your variable represents what you don't know. So let's call P for profit. So he spent a total of $2,600. $2,600 is what he spent. And then plus his profit, the P, plus his profit will give us the total price, which was $4,500. So once again, we've set up part to whole. Part of the money is how much he spent. Part of his money is how much he's going to make. And together, that gives you the total amount of the car, how much the buyer is spending. So we have $2,600 plus P equals $4,500. Let's take out how much money he's spending, and that'll leave us with the profit. 2,600 minus 2,600 cancels out to 0. We're left with just finding out about his profit. P equals 0, 0, borrow here, 9, and 3 minus 2 is 1. So his profit equals $1,900. Let's try this example. We have 9.2 plus x equals 23.7. I'm going to rewrite the equation here. I'm going to use the inverse operation, the opposite operation of addition, which is subtraction. The opposite of adding 9.2 is subtracting 9.2. And remember that subtraction property of equality tells us that we have to subtract the same number from both sides. 9.2 minus 9.2 cancels out to 0, and we've isolated the variable. We've gotten x alone. 7 minus 2 is 5. 13 minus 9 is 4. And we borrowed, so that's a 1. And remember to bring down your decimal. So x equals 14.5. I'm going to use substitution to check my answer. 9.2. For the x, I'm going to substitute our answer, 14.5. And if I did it correctly, my answer should be 23.7. So I'm going to add my decimals by lining them up. 2 plus 5 is 7. 9 plus 4 is 13. Carry the 1. 23.7. And yes, we did it correctly. So x equals 14.5. Let's look at our next example. A plus 13.82 equals 2.6. So here I'm going to subtract 13.82 from both sides because that will help me isolate the variable. I'll be able to get A alone by using this inverse operation of addition. Opposite of addition is subtraction. Subtraction property of equality tells me to subtract from both sides. This cancels out to 0. I've gotten A alone. And here, 2.6 is not large enough to take away 13.82, so I know I'm going to have a negative answer. So I'm going to take 13.82 and subtract 2.6. Reverse it so that I can subtract the numbers. Line up the decimal. 2, 8 minus 6 is 2, 3 minus 2 is 1, and 1. And the negative was larger, so my answer is going to be negative 11.22. Let's go check our answer by using substitution. In place of the A, I'm going to put negative 11.22 plus 13.82 equals 2.6. Remember in the lesson about adding integers or subtracting integers that when the signs of your numbers are opposite, these are not integers, but the same rules apply for decimals. When the signs of your numbers are opposite, you're going to subtract. So I'm going to take 13.82 and subtract 11.22. 0, 6, 3 minus 1 is 2, 0. So 2.60, we don't need the 0, so 2.6. Is that correct? Yes, it is. So our answer is A equals negative 11.22. Here's a word problem using addition equations. A real estate investor bought a home for $113,000. After spending $40,000 to renovate the house, she sold it for $195,000. How much profit did the investor make when, she sold the house? So she originally bought the house for $113,000. Sorry about that. After spending $40,000 to renovate the house, she sold it for $195,000. Okay, so then she spent another $40,000, and then she got to make a profit, her P, her profit, and that equaled the total price of $195,000. So we've created a part to whole model. Part of the money was how much she spent for it when she bought it. Part of the money was how much she spent on renovations. We'll call that spent on purchase price. And then this is spent on renovation. And then part is what she gets for profit. And that'll equal the entire price. So let's add our first two numbers. 1, 5, 3. And then plus the profit will give us the total price. Now let's subtract from both sides. And P, her profit, will equal $42,000. So how much profit did the investor make when she sold the house? She made a profit of $42,000. Let's add up all the amounts, her profit, plus how much she paid for the house, plus the renovation, and see if it totals $195,000. And yes, it does. So all these parts added up to the total price. So remember to include your unit, and her profit was $42,000. Here's another example using addition equations. Wolfgang Amadeus Mozart wrote his first piano sonata in 1762 when he was only 6 years old. And what year was he born? So if you take the year that he was born, add 6 more years, and that will equal the year that he wrote his first piano sonata. So here's his age of 6, the year he was born. This is years past, because 6 years passed when he became 6 years old, and this equals the time of the sonata. So we're going to subtract 6 from both sides. That'll move us back in time 6 years. And the year that he was born was 6571. So Wolfgang was born in 1756. Let's check it and make sure that we're right. So let's take his year of birth, 1756, and add 6 more years. The year he was 6. 6 years passed by. And we get 1762, which is correct. Correct. So in what year was he born? He was born in 1762. And years don't have any type of unit, so you could just leave it 1762. Thank you for watching Educator.com.